Hi, I'm Veronica Manuel, and I'm joined by my friend and robotics researcher, Nico Z from Carnegie Mellon University to discuss artificial intelligence and robotics. Nico, thank you so much for speaking with me today.
Of course.
So it wasn't that long ago when I visited Carnegie Mellon's Robotics Institute and I saw a bunch of the robots you guys were working on, and I even had a snake robot climbing up my leg. So I'm wondering, what are some of your favorite robots out there?
I like a lot of the sort of old school pathetic robots. All these like newfangled like machine learning robots aren't really aesthetically my thing. I love if you ever seen the video of Asimo, the Honda robot falling down the stairs, or Big Dog, the big
Yeah,
Boston Dynamics robot slipping on ice.
yeah.
Um, love those things. The Roomba with a knife like taped onto it, that's like to me like perfect robot. And
So what is
I also really love. I don't know if you've ever heard the artist Arthur Ganson. He's not doesn't really do robots, but he does machines, and they're really wonderful.
So what is it about these like lower IQ robots or like older versions of early robotics? Like what is it about those? Is it nostalgia? What is the charm that you see there?
Yeah, I think there is something charming to a robot attempting something and failing to. I think it makes the mechanisms by which it works more visible. And then I think you see one of these robots today, these Boston Dynamics dogs that can just run upstairs, that can do backflips and stuff, and you
Mhm.
start to imagine that it's doing stuff in the same way that we do stuff. I think it's very easy to we do it with cartoons, we do it with rocks and computers. We anthropomorphize everything. And if it looks like a person and it acts like a person, we will put that on it. But it's those moments when it fails to reach that place where it actually you can see how it works better, and you can understand why it's doing what it's doing better through its failure. So yeah, those are my favorites.
Yeah, it's almost like how you would laugh at a toddler falling down the stairs. Well,
Yeah, but
you wouldn't want to
also
laugh if it's
so
falling
much
down
of
the
what we
stairs.
know, yeah, but so much what we know about human perception and human brains is from that process of uh, watching children, right, and watching people
Right.
who, uh, and also like for example, there's that wonderful experiment where they they figured out when children have depth perception, and this actually ended up helping robotics later. But they put a child on a big piece of glass and they have that child crawl, and a baby will just crawl right across the glass. A toddler will suddenly stop and look and be afraid of falling. So there's
Mm.
this moment where you have enough spatial reasoning to understand I'm moving over this, but I can see under me and I can tell that that depth is far and I can be afraid. So it's kind of cool.
Yeah, it's interesting how we get older and sometimes fear of heights or other kinds of phobias arise as we get older and more knowledgeable, and then have these preconceived, more solidified notions of what the world should be and shouldn't be. And, you don't expect that as you age, that sometimes those fears emanate more powerfully than when you're younger. And then when we
Yeah.
think we're all courageous. So I do want to talk about your biorobotics background. I was very lucky to see firsthand some of the work that you were toying around with in the lab. So you do a lot of stuff with medical surgical robotics. And I was wondering, do you think that that is kind of far off into the future? I know that there are some robotic surgeries occurring already, but how commonplace is that really?
Yeah. I think it's interesting because I've been working now at CMU for like 13 years. 6 or 7 of those years have been in medical robotics, and it's academic robotics. So what we are doing is kind of future facing. We are sometimes things are spun into products outside of, and that's happened a few times with our lab, but a lot of the time we're looking at stuff that's not going to be implemented in the near future. These are sort of more far-reaching things. So I think when we talk about robot surgery, it's interesting because the most common surgical robot is this Da Vinci surgical system. So it's a laparoscopic robot. It can reach inside you, and it's teleoperated. The original intention of it was to let a surgeon from anywhere in the world do surgery anywhere in the world. Hilariously, now all we do is we put the surgeon in the room with you, and he's just next to you doing the surgery.
Right.
And so, yeah, it's interesting. I think that right now, for example, most appendectomies are done with a robot, and it's now commonplace enough that people don't really consider these laparoscopic surgical systems robots. I think that's a pretty common theme. As soon as something works really well, we stop thinking of it as a robot. We just start thinking of it as a tool.
Right.
And we sort of, again, it's about that visibility of, when it's failing to work perfectly. There's that great Heidegger, who's a philosopher, has that wonderful tool analysis that the hammer is invisible to us until it stops working as it should. That we're just experiencing the world through the hammer rather than experiencing the hammer. And it's a similar thing with robotics, where when they really, really work, they become invisible. They become tools. You just say, I had an appendectomy. You don't say, I had a robotic surgery.
Right.
So it's a lot more common than people think. It's just like, what do people consider robots? Because it's still operated by a human, but it's doing things like removing tremors, amplifying motion, and allowing surgeries that we couldn't do before.
Right. And for our viewers, when we talk about telemanipulated, just to clarify, you're talking about the surgeon is in the room or, somewhat close by, and they are essentially manipulating computer images or guiding the needles or clamps, or articulating the arms of the robot using some kind of a visual interface, a graphical visual interface on a computer.
Yeah, so
right.
It's actually a little bit more direct than going through a graphical interface in that sense. It's a stereo camera, very small stereo camera, and then kind of like VR goggles, they show two screens that give you a stereo perception that as if you were like inside the body. So it's meant to be very direct. There's also simulation systems where you're interacting with a virtual world to train surgeons, but over and over again, they found that those have a very limited set of, like, there's a limit to how much you can learn from that. At some point, you just have to start doing surgeries. Does that make sense?
Yeah, definitely.
Yeah. So it's it's very, very, like, it's meant to be as accurate as possible to the human's perception and also their movements. So not augmenting much or doing anything other than very, very small changes.
Okay, cool. So it's essentially they're looking in, as you said, through stereo vision at a feed, the camera feed of the actual robotic tentacle, I guess.
And they could be doing that from anywhere in the world. It just happens to be that that's actually not very as useful as we thought it would be. It turns out that if you're the best brain surgeon in Germany, you're not going to be doing a surgery in, southern Ecuador, because there's enough people in Germany that need a brain surgeon that we just don't see it. People just fly to Germany to get their brain surgery.
And in this sense, there is a dehumanizing possibility of being able to look into this stereoscopic visual feed and be cutting someone open, but not really know who they are, not have the bedside manner to have gotten to know them.
That's pretty common with surgeons. They're not very known for their great bedside manner. They leave that to the other doctors. They just come in, do their gross stuff, and get out.
Right. I guess if you're put under anesthesia, then there's no need for good personality there.
Your GP takes care of all that, and then they just send you to the chopping block.
No comment. None of the people in my family are also surgeons watching this. So, I wanted to ask you, are telemanipulated robots or autonomous robots more practical in surgery at this time?
Yeah, that's a great question. I think that there, so the most, I would say that the nearest targets for automation in surgery are small repetitive tasks, things like suturing,
Hmm.
ablation, which is some way is cutting away tissue
Right.
or incising tissue,
Hmm.
can be like you can be separating a large membrane from a liver, for example, or there's a pericardium over the heart,
Hmm.
and you can be it can take quite a while to move a lot of this tissue, and so
Hmm.
that you can imagine might be an okay task to automate.
Hmm.
Um, the issue is uh, that they're also not super hard. Like laparoscopic surgery is interesting and a good target for automation because it's inside the body. It takes a lot of dexterity, and it's like it can be very strange feeling to be handling tools out here,
Hmm.
seeing the view from an endoscope inside, and
Right.
sort of coordinate all those things. And it's
Hmm.
practice. You get good at it. Surgeons get very good at this. Um, there's an opportunity to lower the training that you need to do it using these sort of teleoperated robots that can um, do some of that mental arithmetic for you, and sort of they take care of where the tools are relative to space, and you just worry about doing the surgery. So that kind of like mild automation, I would say it is,
Hmm.
where it's enhancing rather than or like lowering the cognitive burden on the surgeon. Those are already being done. The small automated tasks like suturing, I think that's a near future thing, but it remains to be seen whether there's actually a market for it. A lot of these tasks take a while, um, and but they also aren't difficult, right? So,
Right.
I mean, difficult for surgeons. But I think you could teach someone how to suture in not much time at all. For them to get really good at it is going to take
Right.
years, but
Hmm.
that's it's not a huge burden. You just do a few bad stitches at first and then you get better. So full automation in surgery, that I've seen more in sort of like battlefield scenarios where you wouldn't have personnel on staff, um, where you'd need something like that. And so there is some interest in the military, but even that, people are looking at more sort of how can you make the task a little easier for a less trained person to do it,
Hmm.
much more than automating. And also, like the FDA, for good reason, is very hesitant to approve a automated surgery. There's a lot of risks involved, and like there's no such thing as perfect software. So it's a very high bar to clear.
Right. And we will touch upon Neuralink a little later. But before we do, I saw that in some of your tissue analysis when you were detecting tumors from like hard tissue versus soft tissue,
Mhm.
that you were using active learning. Can you explain, what reinforcement learning is? What is
Sure.
active learning versus passive learning?
So active learning means that you need to interact with your environment in order to learn about it.
Hmm.
Um, an example where this is not the case is, for example, these object detectors. I can just show you 1,000 pictures of cats and 1,000
Hmm.
pictures of dogs, and you can start to differentiate between them. You don't have to like touch a dog or run around to go find dogs to do that. Is probably a better example. So
Right.
active learning means that you have to interact actively with your environment. When you're a robot, that means going and manipulating or moving about the environment in order to get more information about it. So in our case, we can't just know what's under the tissue. So we have to actively probe. And we're using, in that case, a fairly simple uh, Bayesian estimate of what's underneath the tissue to try to estimate where these denser tissues are. Tumors
Hmm.
are normally denser, and one of these things about these minimally invasive surgeries is that when you're using the tools, like really practiced surgeons can actually feel through the tools, through this long stick into the human. But if you're doing a liver excision and you want to make sure you get the whole tumor and you're in the exact right place, you open up the whole person, you pull out the liver, and you literally just with your thumbs feel through it until you feel a lump. And
Mm.
now you know you're good. And so we are trying to add that capability back into these minimally invasive systems, because the robot definitely cannot pass that feeling back to you. They're like, the dexterity of your fingers is so subtle. It's amazing what we can do with our fingertips. And the robot's never going to be able to A, collect that much information, and B, pass it back to you in a way that's understandable. So instead, what we do is we automatically palpate this in, let's say, a prostate or a liver. We find these dense areas, and as we're going, we're sort of learning an estimate of the stiff and unstiff areas of the tissue. So,
Yeah, that's cool. And it's been several years, but I remember actually seeing you kind of playing with soft, squishy
yeah.
kind of like a prototype of what you're talking about, which is soft tissue, and then having something more dense in there, and
Right.
just programming.
Yeah, and
The
we're also using all sorts of machine learning nowadays. Like we're doing ultrasound guided needle insertion. So
mm,
trying to find vessels and then automatically put a catheter into them um,
hmm
to do. So it's like if you mess up putting a wire into a femoral artery, you make a big mess and you made things worse than they started. So
hmm
if you're helicoptering out somebody from a car crash, that's not going to be the first thing you do, but it might be the only way to get enough blood into them that they'll survive. So if
hmm
we can make this task way easier and almost automate it, we could, for example, you put a device on a person, it scans, it finds the vessel, it asks it asks you whether it's okay to poke, and then it automatically puts in this guide wire for you. So and that for that we're using all sorts of, and this is more passive learning, where we just feed it a bunch of ultrasound images that are hand labeled by people and by experts, and then it learns to recognize these vessels and what they are. So yeah,
so
there's a lot of kind of machine learning we use here.
So to paraphrase, that machine learning is kind of an umbrella term for a lot of different algorithms out there. And
Yeah.
you have reinforcement learning, which is essentially having a set of inputs to the system. And those inputs, either if they're active, that the system has to actually collect feedback on its own
Uh-huh.
actively to process and then produce an output. And then
Exactly.
passively is you just feed it all of that information, I
Feed
guess,
it.
in one
And
go.
reinforcement learning is like a subset of active learning in some sense, because reinforcement learning means the way that you teach it is you give it rewards, or you punish it, you give it negative reward as it goes through in the environment. So, for example, a famous example is these video game playing robots, where if it gets points, you give it a reward. And so over time, and the very difficult thing is, how do you know, because you did a lot of actions leading up to that reward, how do
Mhm.
you know how to parse out that reward such that it learns something useful?
Right. Yeah, and of course, it takes a lot of coding prowess and years of experience, just knowing from the base, layers of the computer, from the hardware all the way up to what you're writing on top of the compiler and stuff. That to
Yeah.
know, how to even get to the point where you can actually program the algorithm to, either learn from the steps that you already took or only pay attention to the steps that are
Mhm.
relevant that you took, et cetera. We don't have to get into coding philosophy here,
Well, I
although,
mean, it's
yeah.
interesting because I actually am not sure that it's very difficult anymore to do
Mm,
that. Um, Getting the code to run to learn something is actually not very hard anymore. There's all these really wonderful tool sets that people have developed for machine learning, which actually, following a pretty simple tutorial and with a well enough, a good environment to learn in, where you don't have to worry about how it moves through the world, it just does.
mhm,
That is not hard at all, I would say. But so you can like make something that learns Mario pretty easily.
mhm.
But the really, really hard thing about all these things is these reward functions. How do we decide what a good thing is?
Mm.
And
Yeah.
designing those reward functions is really difficult. And the other hard thing is getting good data. There's a thought that the big leap in machine learning that we've had, there's been things like all these network architectures and stuff. And there's a thought that maybe actually it wasn't any of those things. It was actually getting the data sets made that
Right.
actually, so we didn't have major movement in image classification, not to the level we've seen until ImageNet, which was this giant database. And so yeah, it's an interesting question of like, is it really the algorithms that are that good, or do we just have so much information now,
Right.
and are our rewards functions good enough to learn
Mm-hmm.
something that seems useful?
Right. I see. I see. Yeah, I did ask a question kind of along this philosophy in my previous episode about is it the data, for example, that is creating these amazing algorithm or amazing and accurate outputs that we're able to use on a day-to-day basis, or is it the cleverness of the algorithm itself? So it seems to be more and more popular consensus that the data itself is what's driving the
Yeah,
usefulness and the accuracy of these AI systems being able to add value.
yeah,
Truly.
and also it's where all the negative things come in, where all the
Right.
bias, all the issues you have is always going to be what's your reward function, what's your
Mm-hmm.
data. If your
Mm-hmm.
data is bad, or if the way that you are rewarding this thing is not going to encourage it to learn the right thing, it might seem to work, but these edge cases that it hasn't run into, that's again, it's the visibility of it. You start to see, oh, it actually hasn't learned what I thought it learned, right?
Right. Yeah, I want to transition into soft robotics. So, soft robotics is essentially the field where robots are made themselves of materials that are soft in texture. And
Yeah,
so they have totally different properties of what we typically think of when we think Terminator style or Boston Dynamics big dog robots, right? Hard, clunky metals. So, what is your opinion on the field of soft robotics?
I think it's really cool. We've there's a wonderful person here named Chris Atkinson. He designed. He's been working in that field for ages, and he's actually, if you ever saw the Big Hero 6 movies,
Mhm.
he did the robots that inspired those.
Oh, wow.
Um, really, really wonderful person, and a great artist too. Um, and I also think, but I think the hard thing about it is that we as a society have gotten really good at making hard metal things that go
Mhm.
exactly where you want them because everything has needed that. Like our entire economies have been based on that necessity. And I think that when you're doing soft robotics, you're starting at a pretty big disadvantage in that you have to often invent the most basic things, how it moves, how it supports itself. We've gotten really good at making electric motors, and so making soft bodies and brains for these robots is very, very difficult. So I don't think we're going to see them in our lives very, very soon, like in our daily lives. And again, if we do, we won't probably think of them as robots. But yeah, it's really neat. I think they're really, really fun.
So, what about shape shifting robots? I was just scrolling through the internet and it's, what do you call it? Stumbled upon was the website where you could discover all sorts of random
Yeah.
things, right? It wasn't the stumbled upon website, but I happened to stumble upon randomly another CMU researcher who works in soft robotics, excuse me, shape shifting robotics, where these robots, you can apply a magnetic field or heat, for example, to change the material's shape. And
Hmm.
so, what do you think of these robots? Like, is there a lot of applications for this? Is there a lot of advancements in this field right now? Like, what's the general direction there?
Yeah, I think um, both of those things I think are really wonderful because they're expanding. They're really broadening what we can do. Um, Whether they have applications, I think, robotics is kind of always looking for applications. One classic one for soft robots is moving through the body or moving through rubble in search and rescue. You need to be able to squeeze through little things and then be rigid for other things, to like climb stairs or do surgeries, right? Um, these like especially very very small magnetic like swimming robots, for example, which wouldn't have their own actuators, they'd be controlled by magnetic field outside the body, are really neat because you can make things that are very very small that could, you could never make an actuator that small. There's not, bacteria can do it, but we're not good at it yet, and it's similar to soft robotics in that there just hasn't been that much work done in that field. We've been making engines and electric motors for hundreds and hundreds of years. So yeah, we're not making soft bacteria flagellum yet.
Right,
Um,
right, right.
those are miracles of engineering, but we have nothing close to that. But I think there is like, yeah, there's some really really neat stuff to be done in that field, and yeah, but it's always robotics is always trying to like look for an application because um, it's an obviously interesting thing, but often these things are far enough in the future that like it's hard to point out exactly what it would be
Right.
useful for. We can talk about, oh, it's great for search and rescue, but the truth is not that much search and rescue happens, and when it does happen, you need very robust tested tools.
Mm-hmm.
And I work in academia. We have those tools. Like our snake robot was sent down to Mexico City during the earthquake, for example. I went down with it and we searched the rubble for bodies, and it was very interesting. But it was also like, um, I think one thing that a lot of people have said is that we need to test these things. And we've been lucky in that we've gotten to test this robot for a long time. And so we
Mm-hmm.
were able to just go and do this. But there's a lack of, you know, sort of preparedness for these things, and frankly, they're not very common. So there
Right.
is not a huge economic incentive to keep these things up to date. The
Mm-hmm.
robots that are going to succeed are in manufacturing because we're already using them.
Mm-hmm.
All this stuff, and surgical robots that are assistive. There's a fairly big market. Johnson just bought all these surgical robotics companies, but yeah, for the soft robotics, and I think they're still in an early enough stage that we just don't know what they're capable of.
Mm-hmm. Yeah, so I was curious. We were talking earlier about how to program the rewards functions to properly create a useful output from these AI systems. You know that ChatGPT has made large language models very famous to most
Mhm.
people now. And I was curious, how do you see large language models fitting into the field of robotics?
I think one big shift that I think is so important, and I think is kind of amazing about them, is they are leveraging this transfer from image to language, back to image to language, back to image. And it's a very important part of how human cognition works. I would never say that it's like accurate to how human cognition works because we don't know how human cognition works, but it seems like it's working very well. And I think what it's going to open up for robotics is the ability to interact much more fluidly with, first of all, people. So going from, the Alexa style, we get really good at recognizing certain vowel sounds and then guess what the whole sentence means, to being able to form and have convincing and thorough conversations.
Hmm.
The I think that the tough thing is going to be that not everybody has the resources to build these models. So right now we're in this flush of, oh, anyone can use it. It's like, yeah, just use the API. It's free. Just
Right.
use it. And there's so much money in it right now that there's this flush of like, oh yeah, we'll just build a large language model. The fact is, a handful of companies have the resources and power to train these models and then also to keep them running. So I'm not sure what their business model is looking like, but you can imagine 4 or 5 large companies able to run these models and
Right.
having to pass everything sort of through their API. People are already starting to get frustrated with Google's control over their own API, where they're like, oh, ChatGPT used to do this and now it doesn't, and I need this for my work, or it isn't generating paragraphs that I find as funny anymore. you know.
Right.
Um, so yeah, I think they're very, very powerful, but they are really, really data hungry and power hungry to maintain. So maybe we'll be able to sort of reduce them in size and train them better. But to me, there seems to be like you know, a dysfunction in the amount of information that these things need to consume in order to appear intelligent. Reading millions times more than a human can read in their lifetime to seem kind of smart. You know what I mean? Like
Yeah.
it should take a little bit less than that in some sense. And it's they're consuming such an enormous swath of information that's really, really hard. Like we were talking about, is your data good? It's really hard to tell whether your data is good. And it's really hard to tell whether the output is predictable and useful, which is really important in safety critical scenarios, which robotics is constantly having to deal with. So I think it's going to open up a lot of really, really fun possibilities, but I'm hesitant to say it's going to like fix all the problems we've been having identifying objects.
Right. So you were talking about how a lot of the image classification algorithms really seem to produce useful output when they were met with ImageNet, like vast amounts of image
Mhm.
data. In this sense, I wanted to explore this idea that you were talking about. If a few key players possess like a lot of the data scraping tools and thus hone their own AI tools and then produce amazing outputs that are valuable to society. How do you see that decentralizing, maybe not necessarily for cryptocurrencies, but a decentralized approach as a strategy can help turn the table on giving power to those open source coders, maybe the small coders without a lot of funding? How would a more decentralized approach look? For example, do you see that as something feasible?
Yeah, I think that is part of the problem with these enormous networks is that they genuinely require so much literal electricity, right? Like
Yeah.
that it doesn't matter if we just do it on a bunch of phones or a bunch of small desktops. The fact is that energy is going to someone's going to have to pay for that energy.
Hmm.
Um, we've seen it with the sort of centralization of crypto mining, for example,
Hmm.
where even decentralized networks, um, you can end up with this coalescing of um, buying power, for example, in like Ethereum or Bitcoin, where you've got these older legacy networks that there's a few really, really big whales that have a lot of the sort of buying power in this economy.
Right.
I think, and that's partially because of the power hungry nature of these things. I think it's a similar kind of problem where you could train, a smaller subset on your computer. You could learn small useful things, but there's something about these learning algorithms that's requiring too much data
Hmm.
and
Hmm.
requires too much computation, even just to run a feed forward, like a prediction, which
Right.
is what like a deep, what's it called? Stable diffusion. You give it a prompt and it runs it forward through the network and it gives you an output. That's a very expensive I mean, it seems instantaneous, and it is,
Mm-hmm.
but for the volume of things that you would need to, for example, navigate a world where you're constantly having to look at the world, and
Right.
then imagine that there's 7 billion of those robots. It's not really feasible. So I think there's an opportunity in some future where these networks are easier to train and learn better from less to
Mm-hmm.
decentralize. But I do think that, yeah, it's unfortunate, but all these giant data sets, which we don't even know what they are, that's, I think a lot of the value of these companies is really in their data sets and not in their algorithms.
Mm-hmm.
Um,
Definitely.
yeah, all the speculation on Uber, right, when they started doing self-driving, even though self-driving never panned out, they still have a giant data set
Mm-hmm.
of driving that almost nobody else has. And that, I think, was a lot of the speculation that was happening on that company, was this
Mm-hmm.
giant data set. And there's just no good way to decentralize a data set right now in that way, because the way it's collected and the way it has to be standardized for it to be consumed,
Mm-hmm.
um, is a lot of work, a huge amount of work.
Yeah. And so what you're saying is essentially these natural pools form, whether they're big tech or those who own a lot of data and are selling it, for example, that a truly decentralized approach is idealistic, maybe to the point
Yeah,
of
I would say naturally pool.
right, right,
There's some very
exactly.
heavy incentives to pool.
Yeah.
Um, yeah,
So
I
that's
think
where I
I
was going to
think
paraphrase
more
there. Exactly.
regulation would help,
Hmm.
because it would force these companies to sort of break up their component parts,
Hmm.
where you wouldn't be able to have an advertising company as big as Google own as much data as they have, and it would force a lot more collaboration, and probably opening up of data sets. There's a lot of open data sets on like Kaggle and stuff, but
Hmm.
it's like even storing that much information. But again, it's like the volume of the stuff is just impossible it makes it impossible to democratize.
Mm. Yeah, it's interesting. I think fundamentally that in order to make your data valuable, especially aggregated, pooled with other people's data, is that someone has to clean that data and organize it in a way that it can be properly ingested by an algorithm that can produce valuable outputs from all of
Hmm.
that mass data. And so, in a way, we voluntarily give up that information on the blockchain, right? Just by nature of using the blockchain, or in our social media conversations, which are done open, in a public manner, right? Relatively speaking, who owns the platform may not believe it's public information, but
Yeah.
for the purposes of me saying that. So, it sounds like to me that maybe the trickiest part of a decentralized approach to individuals owning uh, their sovereignty and the value of that data, however many dollars their data is worth, is really in collectively understanding or formatting it in a way where it can be ingested, you know, and whether that's
Yeah.
by the pooler or by the individual, and it is kind of a neat way to look at the problem. I think that there's a lot of hope that this just decentralizing something in general is an advantage to looking at a problem. This is a new concept that I'm starting to see. That centralized AI, for example, has these flaws. So why don't we decentralize AI? Well, but you're saying that there's other problems inherent in that approach as
Yeah,
well.
you can decentralize the algorithms. You can decentralize the computational processing to some extent, but
Hmm.
there's yeah, the problem is it just takes too much data right now. I think
Right.
anyone would agree with that. Um,
Right.
and yeah, I know that we don't. Because I think that the only really good solution to the way these companies are using our data is, and the only thing is frankly more regulation of them,
Hmm.
which kind of flies in the face of what the sort of decentralizing approach. But I just over and over again, these companies have shown that they are completely irresponsible with this data and how they use it. The Cambridge Analytica thing. And rather than, and I'm not suggesting that, oh, well, the government should have all your data, but rather, financial incentives and legal incentives for people to be able to band together and reclaim some of that sovereignty over their data. Like they've managed to do successfully in the EU to some extent.
Right. Yeah. Yeah, and we are working, with some customers who are concerned about privacy protections on individuals' data, and looking at some of the upcoming regulations all around the world that have to do with that. So back on robotics and the interface, human AI interface, I have to bring up. What do you think of Neuralink?
Yeah, not a big fan. I take the position that if Elon Musk is heavily involved in something, you're going to have to convince me it's not a scam. He has made some really boneheaded companies in the past. The Boring Company is, I mean, how many ways can you fail to reinvent trains? It's incredible. Like,
Oh my gosh.
so the idea that this man would somehow invent a brain computer interface that's actually useful is, I'm sure there's really amazing smart people working at that company. But like, this is the guy that literally brought a guy in a Lycra suit on stage at a Tesla shareholders conference and said, imagine a robot that's like this. So yeah.
I'm not going to pass any judgment on Elon Musk, but
I just
find
think
it.
that like the brain interface has existed for a long time, right? We've been doing brain interfaces for decades. The really, really hard thing about brain interfaces is that we don't understand how the brain works. We just don't. We have some ideas. We're getting a little bit better at it. But the fact is that the signals we get from the brain, the electric signals we get from the brain, are uninterpretable to us. We just have no idea what's going on. And so what's amazing is you can plug a brain interface into somebody, just anything, almost anywhere in the brain, and you can learn to control things with it. There's this wonderful example when they were first developing these monkeys that were, they had brain interfaces in.
Right.
They were eating off a table, and the researchers were recording the brain signals that were happening while their arms were moving. And then what they would do is try to correlate those and learn a model of what the brain was trying to do. And then when they detected that group of signals, they would move the arm in the same way, a robot arm. And then what they did is they hid the monkey's arm behind a screen. They put a robot arm where the monkey's arm was, and it was able to mimic the monkey's arm movements.
Right.
And there's this famous story from Carnegie Mellon, actually, where the researchers go away to lunch, and the monkey's moving an arm over here, and an arm over here is feeding the monkey. They come back from lunch, and the monkey has stopped moving his arm, and the robot's still feeding him. And the monkey has learned to isolate the signals that just move the robot arm and not move its arm. And has learned to use this interface in a way that was completely unexpected. The same thing when you plug rat neurons from your ocular parts of your brain into other parts of their brain. They literally unplug the eyes, plug them in somewhere else, and they're still able to detect things in front of them. We don't know what they're seeing looks like, but like the brain can learn. And so like, if it's that flexible and that malleable, you can plug something in and I can like learn to do something with it. But like, do you understand what that signal actually means? Or is your brain just adapting to whatever's, it's very good at that. And then the other thing is, I've not seen a convincing reason why we need brain interfaces. Assistive robotics has been getting along really well by reading people's intentions in other ways through muscle activations, and also through brain interfaces, but simpler ones that like, I don't see it working for them. But best of
So,
luck.
you don't see any cases yet, right, for the need for a human brain interface. You're not worried
I don't
about.
think you could. I find it I find it nuts that the FDA cleared testing of these things when like there's so little reason for them to exist, and there's so little proof that like we understand what these signals mean, and how to put things back into the brain. Forget it. Like I said, like what your fingers can sense, like that, it's magnitudes above anything that our current sensors can make. So like, what are you putting into the brain,
So I guess just to explore that a little more deeply, maybe that the implanting a actual chip in the brain is, in your opinion, not as useful. But what about like this idea of sci-fi cyborgs, right, where there's other kinds of ways of appending articles to the human body, or articles,
Yeah.
assets, you know what I mean.
There's a
It,
wonderful artist I love called Stellark. He's an
uh-huh.
Australian artist, and he, instead of writing about it or like thinking about it, he literally just grew an ear in a lab, had it surgically attached to his arm illegally because no surgeon would do it. So he had to do it sort of under the table. And then it had a Bluetooth microphone in it, a fake ear in his arm that would live stream to the world at all times. So he
Huh.
completely gave all of his privacy, and he just added an ear on his arm because he thought it was fun. Of course, it got terrifically infected. It was a disgusting. It almost killed him.
Uh-huh.
So there's people out there, or like Donna Haraway, who's a famous writer. She wrote a lot about these kinds of things. People are out there doing it, and like you could make a very simple argument to say that these, we carry around our phones everywhere. Those are kind of these augmented things, or even the amazing things we've been able to do with assistive devices and prosthetics. So I think we're already there. And I think that if like there's like two kinds of like we're making really good strides in it. I think it's really cool. But often I've found that when people are selling you a sort of like immersive cyberpunk experience, it's important to ask questions like, okay, who is making these devices? What are they connected to? And like, are they real? Really, genuinely, like we can talk about, oh man, if you had like 6 arms, who would make those arms and what are they connected to? But like, why do you ever need 6 arms? Would our lives be materially any better? And like, how are we going to even start to get there?
Yeah, it's interesting. I had to ask about cyborgs and Neuralink and this kind of stuff
Yeah,
to you because, you work in the field.
fun
Okay,
stuff.
so one thing that is really cool to me is that you have been into art for a long time. Ever since I've known you, you have been painting or using all sorts of media, 3D rendering from scratch. So you are now technically an artist in residence at Carnegie Mellon.
Yeah,
Um,
that's my
how
title.
Yeah. Yeah, I mean, you spend your days doing, biorobotics research, and then
Mhm.
your title is artist in residence as well. How did
Yeah.
you finagle that title? How does art factor
Well,
into your work?
I would say it's interesting because like I went to art school. That's my training, is an artist. I got this job because I'm good at programming, and I've just been working in this. I've always been interested in robotics, but I would actually say that the robotics work feeds my art and not the other way around.
Hmm.
Um, I have this job because it's interesting. I get to, and I get to, like, a lot of my art is about algorithms. It uses algorithms. It investigates how these things work, kind of that same project of making things more visible.
Mhm.
Um, and one wonderful thing about this job is that it allows me to stay up to date with not just like what's new, but actually how it works.
Mhm.
Because I'm, having to implement this on real world systems,
Mhm.
not just like talk about it. And there's something I think really lovely in the same way that like working with your hands on a piece of art, like if it's art about code and it's art that is code, really being immersed in it. And like it's really important to me that my art performs itself, that it's not a recording of code running, but that
Mhm.
like there's a, some of my favorite, like I had this one of my friends, Leah Wolfman, who's an amazing artist, and I had this, like we always trying to like make this computation more visible and more physical. Like
Mhm.
we had a project a while ago where we were generating images of the Virgin Mary, um, using, in that case, like a GAN, which is now kind of like old technology because it's like
Mhm.
3 years old. But
Mhm.
and then we were using a water cooled GPU to generate those images. We were passing the water from that GPU, like as it's generating these images and generating this sort of like CG holy water
Huh.
out of them.
So,
It's facetious, right? Like and that's part of the fun of it is like the computer does not know who the Virgin Mary is.
right.
It really can't know that. It
Right.
can generate very, very convincing images that look like completely new images of the Virgin Mary, and they are.
Mhm.
But by sort of elevating it to that level of like, oh, it's now generating holy water, I think I like work like that sort of makes you question, like, well, it's not really holy, it's just water pushed through a GPU that's getting hot because it's like working really hard at faking images, right? Like,
Oh, I see. So what you're saying is that the water in the cooling tubes for the GPU itself
yeah,
is in a way holy water because the computer is using that water to cool itself as it renders holy
yeah.
images.
There's this and I'm obsessed with like Catholic imagery and stuff like that. And there's this idea, for example, the Virgin of Guadalupe, which is this venerated Mexican image.
Mhm.
The reason it's special is because she appeared, to an indigenous person in Mexico. It's the first time the Catholic Church recognizes that the Virgin Mary spoke an indigenous language, which is interesting. And um, it's like this contact. You have this contact with this metaphysical unknown, right?
Mhm.
And that impression causes him to make the image of the Virgin Mary that's now venerated. So that image of Guadalupe was originally painted by this man who saw her appear in a vision and
Mhm.
in a miracle, right? And so obviously the computer is not having that experience every time it generates an image of the Virgin Mary, right?
Right.
Um, and so like I like stuff like that because it's not lying about what the computer is doing. It's not misusing the algorithm. The algorithm's doing exactly what it's supposed to do, and it's doing it very well.
Mhm.
But by changing the context slightly, you can, I think, talk about what is it really doing much more clearly.
Right. It's like that you yourself are running generative art algorithms, and then those algorithms are in turn generating physical art in physical
Mm-hmm.
reality, you
Yeah.
know? And that is quite unique. I think it kind of flips the philosophy of who is really creating the art here on itself, because on the one hand, we believe that we are creating the art, by selecting the prompts for the stable diffusion algorithms or selecting the prompts initially. And then that art that is generated then creates something in our physical reality that's different.
Mm-hmm.
And in
Yeah.
your idea that could be art in and of itself. And then for others, it could be money or a new
Sure.
job or whatever, however it manifests in physical reality. That's cool. I had never heard that from you before. And so what a lovely surprise. I want to know, you're kind of hitting on these points of generative, the interface between humans and computers in generating art. What do you think of using Midjourney and, for example, Runway ML? Are these taking away some of the creativity, some of the credit from humans who are creating the art? Do you think that it's just
Yeah,
a
I mean,
tool like a paintbrush? Like what
right. There's a lot of
philosophically?
discussion online of like, again, this data, where's this data coming from? Do I have ownership of the data that was used to train this that can
Mhm.
mimic my style? I think
Mhm.
that's really, really difficult. And I think it's um, unfortunate that the collective bargaining power of artists is tiny. There's very few artist unions. There are very few laws on the books to protect anything except for the largest kinds of intellectual property.
Mhm.
And yes, I think that's kind of unfortunately a lost battle. There's been good work done, obviously, with like the writing union is on strike right now, the TV writers union.
Mhm.
And part of the demands is that we don't resort to these, to replacing people with these algorithms. So I think there's like some power there to slow it down in that sense. But to your question of like who's who's creative, I'm not sure. I think that sort of misses because I think that's a really, really popular and salient question. A lot of people are wondering that.
Mhm.
And I'm not sure it's the right question.
Mm.
Because there's like people who are like, oh, people that do prompt typing aren't artists. And I think that kind of gatekeeping is ridiculous because I really genuinely believe that anyone can call themselves an artist and anything can be art. And the question is it interesting? Are you an interesting artist? There's that idea of Rilke's and it predates him, but I love his writing about it, that art is about this internal truth that you're getting to.
Hmm.
And so if we, instead of saying, is it art? Because who cares? Sure, of course it's art. Are the people writing prompts accessing a human truth?
Mm.
No,
Mhm.
they're writing prompts. Are they making cool images? Yeah, but I also think it's like we tend to underestimate. Um, we tend to overestimate how much people actually want to make images. Like even though it's become very easy to make these images, you actually don't see a lot of people just like making new artists coming out of this. It's a fairly small group of people who, you know, and like an even smaller group of people who think of this as a career. Like I'm a prompt designer,
Right.
right? If this really was democratizing in that way, you would see everybody making stuff. But I think actually most people kind of don't want to make images.
Hmm.
We love looking at images, we love consuming images, but it takes a particular temperament to want to make and want to
Right.
add an
Mhm.
image.
Mhm.
Um,
Yeah, and
and the
there
other thing is, I think it overestimates how interesting images are by themselves. Like if you
Mhm.
make a really beautiful thing, and then it turns out there's this really funny like uh, conservative meme that floats around whenever art comes up. That is basically a group of students are studying an art history class, and he shows them a picture of a Jackson Pollock, and he says, "Go home and write a 1,000-word essay about this Jackson Pollock." And they come back and they all write their essays, and then he reveals, oh, that it's like actually just a palette and it really had no meaning and that they wasted all their time and that art like modern art is useless. But I actually think that's a really good story for almost the opposite reason, that so much of how we care about and interpret art is about the intention and understanding the intention of an artist. And just because something can invoke that kind of response from you where you try to interpret what it means, if at the bottom of it it's either unintelligible to us, like if it's an animal that's making the art, or at the bottom of it, it's meaningless. it's random, then we very quickly lose interest in those kinds of images. And I
Mm-hmm.
think we're going to see a lot of, the places where these are being really pitched to, because they're the only people, again, these are huge, expensive algorithms to run. The only people with enough money to actually like use these services long term are going to be publishing companies. They're going to be, and so they're pitching it to these companies as you can replace all these artists,
Mm-hmm.
concept artists, illustrators, musicians,
Right.
because they're the people that actually have enough money to run these things on a long-term basis.
Mm-hmm.
And I think the sad thing I think about the prompt designing as a career is that hilariously they've already been replaced. One of the first things to come out of Midjourney, I don't know if you've seen this, is a Midjourney prompt generator. It's an AI prompt generator. So you put in something really simple and it sort of zhuzhes it up to produce cool images. And so all of a sudden, all these new prompt engineers are out of a job
Right.
instantaneously. You know what I
Yeah.
mean?
Yeah, I
And
understand. Yeah.
I
Yeah,
think it's
so
really it's a beautiful, they make some amazing things. It's a crazy cool tool. But when you ask, are they real artists? Yeah, sure, they're real artists. Are they making interesting art with it? No. Unless, like, I haven't seen, and I think it's because it's new. It's a new technology.
mhm.
It often takes art a while to understand technology well enough to make interesting things with it. And it being the property of these large companies right now is slowing that down.
Mhm.
Um, but it's too new right now to know what it's capable of. But I don't think that just the images it produces are
Mhm.
gonna are worth it for us as a society to like really worry about. Oh my God, is this art? Like if I like a piece of art, I'm like, oh, that's cool, and then I find out it's AI generated, I lose a little bit of interest because like at the end of the day, there's no one I can ask, say, hey, why did you put that there? Like, why'd you make that mark? It's such a beautiful mark.
Mm.
If it happened accidentally, I'm like, oh, cool. You know what I mean? Like, oh, that's kind of fun. But if someone was like, oh, like, yeah, I hit that, and then when I did that last little mark, like it all came together for me. It's like, you can have a human experience there.
Huh. I heard you say something just now when you were talking about that content creators didn't really have a strong voice in their copyright protections or
Mm-hmm.
intellectual property protections. And I was curious, how do you think that tokenization of art, NFTs in particular,
Mm.
has changed artists' ability to have a voice and have the ability to monetize their own art better?
Yeah, I was feeling fairly positive about it when I first heard about it because of the idea of these contracts they could
Hmm.
build in.
Hmm.
Until I found out that for all of these services, you have to rely on the service provider to actually run your contract. So if it's sold on a marketplace that does not run that code, it will simply not run that code. And so that was a really big blow to it for me because that was really interesting to me. Like like these cryptography algorithms take a lot of energy. And
Hmm.
so to me, there has to be a very, very big benefit in order to justify the expense. And to me, the big benefit was these contracts. And I don't know if it was poor implementation or simply that like there's no real way to guarantee how someone runs your code, other people's code. Um, that and then the other thing is that obviously in order to encode the entire art piece into the blockchain is very expensive. So instead,
Hmm.
you're encoding a URL. That URL is hosted somewhere. It's a link to an image, and
Right.
that's a centralized place. Unfortunately, that
Right.
data rot and like if that company goes under, it's not archival. And then the last thing I think that NFTs have had a lot of trouble with is if the main benefit. So if the main benefit isn't the contracts and it isn't the the what's the anyway, if it isn't the contracts, then the it has to be the provenance. A lot of the big art markets in the world, that's the main problem is
Right.
you get a piece of art, it's worth $1 jillion, you find out it's not real. Or
Mm-hmm.
you have a piece of art, it's worth $1 jillion, and it turns out the Nazis stole it, and actually it's someone else's, and you can't sell it.
Mm.
Provenance is in these giant, and again, these are like big, like the kind of art that I make and my friends make is not being sold at this level, right? This is
Mm-hmm.
for very wealthy people to buy extremely large sums of money that they can interchange as art.
Mm-hmm.
But NFTs are cool because you've got this perfect record of every time they're sold,
Mm-hmm.
except when they're stolen, right? Which happens where people have their wallets stolen and they have
Right.
to complain. And because it's the blockchain, you cannot undo a transaction
Right.
unless you fork the entire currency. So there's workarounds for it. And so you have, sort of like complex undos. But for example, the largest NFT sale in history was done by Christie's, right?
Mm-hmm.
And it received critique even at the time that the actual sale wasn't done on the blockchain. Um, it just wasn't. The actual sale was done at Christie's,
Hmm.
and the money was exchanged at Christie's, and it was interchanged into and out of crypto. But the thing that's going to go on that person's certificate of art, and the thing that's going to matter, excuse me, is the certificate from Christie's, right? And
Okay.
so I wonder, again, with these things, it's like, what is the problem they're solving? Are they doing a good job of solving it? And
Mm-hmm.
for me, the current market of NFTs is not quite doing it for me. I love cryptography and I love cryptographically encoded art. One of my favorite pieces I've ever seen, and this is, I think the fun of it is like this DIY aspect of it. My friend made a cryptography algorithm that you can encode any information into images from Kim Kardashian's Instagram. What it does is it takes the image and then it uses machine learning to to learn how exactly to perturbate this image very, very, very slightly, such that it looks like the same image. But
Mm-hmm.
if you compare them, if you overlay them exactly over each other, it actually produces understandable output.
Huh.
So I think there's some like really, really wonderful, fun things to do in cryptography. In also decentralizing things. My
Mm-hmm.
friend Mary is trying to make DIY estrogen production possible,
Hmm.
DIY insulin production. Like if you could just like grow it in your house, it would suck so much the power out of these companies because there'd be no real way to stop people from doing it.
Huh.
So I think broadening our approach to decentralizing and broadening our, you know, our how we use cryptography,
Mm-hmm.
I think could open up that space again for me. But yeah, I think especially the OpenSea people, it felt like a bit of a rug pull because it was such a cool idea and I really wanted it to work. And then finding out that if you don't sell the thing on OpenSea, it's not guaranteed to do the contract was like,
Hmm. Yeah, well, there are um like for example at Ocean there's an option to tokenize your art using our market, but you can run your own, and of course to your point that this takes a lot of computational power, you can run your own version of our open source code and you can run all the smart contracts on your own,
mhm,
do all the encryption and everything on your own. um, so in that sense, open sourcing the ability for artists to be able to do
yeah,
that is really cool. But having the knowledge and the capability to be able to do all of those things seems still kind of out of reach. And then, even to your
yeah,
point about the archival issue, there's a cool company called Arweave that does decentralized data storage, but it's the way it works, it's not like IPFS, which is commonly used in
mhm,
NFTs. And to your point, there is kind of a centralized pooling of that IP, right,
mhm,
by one company, when you pin your intellectual property there.
yeah,
But in Arweave, it's kind of cool because you will convert your art, right, into your art as a file, right? And it shards up that file and then sends it around to its network of decentralized computers that know how
Yeah,
to reassemble. They can reassemble that art piece or the file, whatever file it
right.
is, because they have the instructions to be able to do so, right? And then there's redundancies built in so that if some of the nodes go down, that the art isn't lost, right?
Yeah,
Um,
or for sure. I
and
mean,
so,
already even outside of that, you see torrent sites rescuing lost code, lost art, because it was decentralized and no one was being paid to save this stuff.
hmm,
Um, and so you end up with some of the only archives and history we have of these things being on like archive.org, being on, which is centralized, but it's user, like what's important enough to archive is up to the users.
hmm.
Um, and you know, I can't remember, but there's a famous example. Like, actually, I remember the person has turned out to be a real jerk. They're an artist uh, who turned out to be a real meaty. So I'm not going to mention them to give them
Hmm.
more clout. But their art was lost and then refound on these torrenting sites, and so they were able to save all of their art, which is a
Huh.
shame because they're a jerk. But it would have been nice if it was art I liked.
Well, so what you're saying is essentially that when you have this peer-to-peer distributed or decentralized network of nodes that are essentially selflessly involved in maintaining records for that network, are you saying
Mhm.
kind of that if art is
Or
lost
maybe
or if it
selfishly, but a diffuse set of um, reasons that they are saving this information.
okay, I see. Yeah,
Does that make
maybe
sense? It's
there's
more
an
likely
incentive there.
that a random thing will be saved because it doesn't have to matter to Google. It just has to matter to somebody who wants to
Right,
seed it and
right, I
let it
see.
live on their computer.
Huh. Yeah. So, like, for example, if something is wiped off the internet or is banned, and then these torrent sites, have the archives stored on people's computers and they can figure out how to recover that art,
Mhm.
then in that sense, that you have a power just in these,
Yeah,
like,
and you're still going to lose things. There's still data rot, and dead torrents are so common, right?
hmm,
But yeah, it feels bad to me to give it to a company, especially whose motivations for keeping it are just it makes us money to keep it.
hmm,
You see like the BBC destroyed, they taped over all their old shows. We only have copies of Monty Python because someone broke in and stole those tapes before they were able to re-record over them. We lost
really?
decades of British television that we only now have like liner notes for, of like, oh, this was on TV today.
Huh.
We have no record of it because the BBC decided buying tape is expensive. We're just going to tape over everything we've ever made. And now those shows would be making them money. So they're kind of sad about it. But imagine all the things that we don't have because it just wasn't worth it to store it.
Hmm.
And so I think
Yeah.
diffusing the responsibility, but also um, the require like why you would want to store something um, might help.
Yeah, of course. Storage, can be on the one hand a cheap, inexpensive way to approach a problem, and then on the other hand can be like even the big guys have their limits to what, like BBC you said, have their limits to what
Yeah,
they can store. Um, and then you always have this hierarchy of what needs to be curated that can be stored. And in that sense, like, yeah, you have these torrent sites or other like deep, dark parts of the internet that are housing different kinds of data. And yet, what we mostly see is what the collective kind of and the algorithm as well wants us to see and has
see.
curated. So we curate and then we have the rewards functions for the algorithms to
Yeah,
serve up,
and they're not very good at picking what we want to see. That's what's amazing. They've got all the data in the world, and we talk a lot about, oh man, the algorithms listening. The fact is, they're actually pretty terrible at guessing what we like. In my
okay.
experience, I don't know if you agree.
I was going to ask you about what you like to watch and what you like to recommend to our viewers, because some of the things that you pick, like maybe I'm a little more easily influenced, let's say, by what's right in front of me to watch. But I find that you actually really do a good job at finding strange things on the internet, bizarre things, art, music, movies, all sorts of
Yeah.
things. And then, like anytime I would ask you for a recommendation, you would surprise me
Oh, thanks.
with what you would
It's funny you
say.
say it because you've
Uh,
recommended me things that I've never heard of and have been incredible. It's an important part of my life. I think
I'm
all
getting
friendships have
into
those exchanges, but I
yeah.
genuinely think that like, yeah, I think you owe it to yourself in today to like go on something that isn't ranked. Just go
Mm,
consume media that isn't sorted by popularity.
hmm,
Just like do it. Like really like it sucks sometimes. It's a lot of it's really bad. But
mhm,
um and I think especially if you're an image maker,
uh-huh.
um there's some amazing people who have a practice of this. But just
So,
consuming things that aren't ranked, I think
mhm,
and trusting your friends and like going to real life events
mhm,
is getting more and more important because I do think that like even though they're not very good at recommending things to us, they're good enough that I'll just keep listening to my Spotify when it's on shuffle. And it
mhm,
might not be the best music I've ever heard or like, enticing to me in the way that like discovering new music by yourself feels so
mhm,
cool. You're like, oh my, what? I haven't heard this. This is amazing. And it's like perfect for me. But it's good enough that like you can like swim in it, right? And it's not work. And that's fine. I think that like that's how we've consumed media as a species forever. That's not a new problem. But I think it's quite a bit of fun to go out there and like yeah, go to like especially like film festivals, stuff that's like really new, untested, or like there's a wonderful thing here in Pittsburgh called the 10-minute Playfest. They have them all over. Everyone has those kinds of events, but like DIY spaces where it's like untested, mostly garbage that and then occasionally the miracle of seeing something that's going to like change you really
yeah.
deeply. So like yeah, I love that kind of stuff, and I think
Have,
that's more than like oh digitally trying to change your algorithm or get out of the algorithm. Like go like there's no algorithm outside. You can just go do and see things.
Yeah. There's have you ever been to a comedy club where you've seen like all the like baby
Oh,
comedians, you
oh my
know?
god, it's
They're
brutal.
so terrible.
Yeah, but then occasionally someone's just like magic and
Exactly, exactly. And you see, all these jokes that are attempted that are things that you wouldn't have thought of or that everyone has already thought of, and you end up walking out of those shows like you really relish in,
mhm.
seeing these
And
failures. But it's like, it's like you want to see that too. You don't want
right.
to just see someone ace it every time, you
And for
know?
me, it's like also so important when I consume art that it makes me want to make more art. And when
Mhm,
I'm passively consuming, and often they aren't challenging you much, which is great when you're just like working and you want to put on a podcast and like there's like a playlist, a podcast to listen to.
right.
Great. There's no problem with that. I have no issue with that. I don't think like, oh, people are zombies. No, obviously not. But if when you have that feeling of wanting to challenge yourself with what you consume, it's I find seeing something really bad and something really good makes me want to make art because you can see where you fit in that spectrum, and it
Huh.
can be like the most freeing thing to see someone make something that could have been good and fail at it and everyone still like have a good time and like
Right.
you had a good time
Yeah.
is like the best because you can walk out of there saying I've got this idea. I don't know if I could pull it off, but all these people in this room are lovely and if I messed it up, I know they wouldn't, it's like that kind of space is so wonderful. So seeking out that kind of stuff is really important.
Yeah. like as far as any recommendations that you had, I'm curious, like specific websites or forums, channels, influencers, like what would you recommend? Maybe your top three
Yeah, I
unique.
I miss old forums, like really niche, strange forums.
Yeah.
Um,
Okay.
there's like a few in Pittsburgh where I live, for like local stuff
Hmm.
that there would be no point in recommending because it'd be like mostly how to get rid of groundhogs and stuff like that. But seeking out smaller sort of internet communities, especially
Hmm.
that are like local to you or that are really, really specific. Like if you got a dumb hobby, like subreddits can almost fill that role of like hyper specific subreddits where it's like, oh, only 10 people do this and we all love talking about it.
Uh-huh.
But there's some joy to like a actual just for that website. And they do exist. They're getting harder to find because Google's getting worse at Googling, which is amazing. They're getting really good at giving you a good enough result. But I don't know
Mhm.
if you've noticed this. You scroll down in Google nowadays. Do you remember like we're old enough now that we remember Google starting. You would scroll and every page of Google was useful. Like
Right.
at the bottom there'd be like really esoteric, strange, probably wrong things,
Right.
but they would still be things. You look at Google now, you scroll 2 pages in, and it is nothing. Like it's amazing. They've got 10,000 results, and there's nothing there. It's kind of
Yeah,
scary.
it
It
is.
really like
It is.
so. It's hard to find those communities, but I would also say in terms of like consumption, um, some artists that I really love that work in this kind of space and like think really deeply about the media they consume.
Hmm.
Um, I mean, like some friends of mine who I can't recommend enough, Claire Heschinger, Caroline Record, um, like just like people who like really, really, really. We were talking about like when this like stable diffusion stuff would make interesting art. These are
Hmm.
people who are like so fluent in their media that they can both think really deeply in it and express things using it so fluently that like oh it's amazing combination. But yeah, Dan Pillis was an amazing artist, Claire Heschinger, Carolyn Record, Mary Magic does like biology art, incredible person. um, and then like people that don't use the technology but work like by making it themselves,
Hmm.
um, are like people like Nikita Daikur, who's a and who else? Takeshi Murata. They're both really great animators.
Hmm.
Um, and then like Dina Kielberman, who did this amazing project called I think it's like I am Google, where she is her own algorithm. She just like when she finds images, she posts them on a giant list of images, and they sort of slowly morph over time. And so, like,
Uh-huh.
as you can scroll through all this, and it looks like a Google image search window, but it changes over time because what's happening is she's just finding these images that match her algorithm. Um,
So,
Oliver Lyric is an amazing person,
uh-huh.
amazing philosopher and artist who talks about like how images are replicated really
Mm.
beautifully. So if you're interested in that, he's incredible. Um, and then like for just robot art, I like it's goofy, but I love Ken Goldberg. And like I said before, Arthur Ganson, who isn't really robots but machines.
Hmm.
And like yeah, there's like it's funny, like we were talking about like stuff that's gone now. There's this artist group I love called the Center for Metahuman Exploration.
Hmm.
And you can't find any of their work anywhere anymore. You really have to dig. It's
Huh.
like old like digital fanzines, but they made the best fucking robot art I've ever seen, and like it's disappearing. And so
Hmm.
like making an effort, like when you find something you love, save it. These things
Yeah.
don't. We feel like they last forever, but like
Hmm.
archiving these things like archive.org and stuff like that are so important. So when you like see a website you love, go to archive, ask them to archive it. It's free. They'll just do it.
Yeah.
Yeah.
Cool, Nico. Well, I really enjoyed catching up with you under the guise of a podcast.
Yeah,
It's been a long time, and I'm really glad that you took the time to chat
of
with me
course.
about this.
You're a lovely person.
And thank you. And I knew that you did cool work, and I had seen like a bunch of that when I visited the CMU lab. But to actually like understand some of these issues in robotics and the art robots kind of machine learning intersection was kind of neat too, because
Yeah,
you're so expert in the robotics, and then you're so expert in the art, and then there's like this like strange gray matter like in between there that's happening, and it's kind
yeah.
of disorganized,
I
but
love that stuff.
you kind of find the uniqueness there,
Mm.
in what other people aren't saying as much, but it was really cool. So with that, anyone watching, please leave both of us comments below, because we would love to hear your feedback. If there's anything that resonated with you, let us know. And don't forget to hit that subscribe button to fool the algorithm into showing you more awesome content like this in the future. Bye, Nico.
See you later.